Okay, today we're going to start a series on how to make an Asteroids game in Unity. In this video, we'll cover the basics about the control of our ship, such as rotation and movement. So, as most of you know, Asteroids is a game with a particular set of controls, where you push a button to impulse and other two to rotate the ship right or left. So we're going to do exactly that. First, the impulse. We're going to add a rigid body to our player's game object and set the use gravity field to false. Otherwise, this will cause the ship to fall and, well, that will make much sense. Now, of course, the rigid body will mean nothing if we don't have a collider in place, so we're going to add that. And we are now ready to create our player script and attach it to the player's game object. First, we create a public variable impulse speed. So, as we said before, our player needs to be impulsed every time we press forward, so here in the update method, which as it says right here it is called once per frame, we'll listen to the forward key. We could just go ahead and type f input.getKey, keycode.w, the key meaning that we want to know every frame we're pressing that key, and not only when it just got pressed down. In that case, it will be getKey down. Now, look at this part, keycode.w. The problem with this is that it will only work with that key. Sometime after that, you may want the player to impulse the ship with the up key as well, or maybe even support a controller. And we will have to put something like input.getKey, keycode.w, or input.getKey, keycode.arrow, and so on. We could avoid this by simply typing input.getAxisRaw vertical equals 1. GetAxisRaw lets me get the value of axis vertical with no smoothing filter applied. This means it will only return -1, 0, or 1 instead of the values in between getAxis returns. 1 being up, -1 being down, and 0, well, not receiving any input on that axis. So why is this important? Well, we only want to know when the player is actually pressing up or W, so we don't need any smoothing applied or to know how much of up the player is pressing. Okay, so now we call a function impulse that we are about to create. It won't be called anywhere else, so we make it private. To move the player, we're going to need the rigid body we added earlier, so we go ahead and create a private variable called RB, and inside the start method, we get the rigid body component and save it into our variable. rb.velocity plus equals transform.forward time impulse speed times time.delta time. So, what does this mean? Well, here I'm putting as the velocity the direction of the movement. Transform.forward meaning that it will go where it's currently facing, and the amount of movement in that direction. To that, we put in the speed, meaning the amount of units per second, and this time dot delta time is the time it took to run from the last frame to this one. So we know a game runs several frames per second, right? A game usually runs in 30 frames per second or 60 frames per second, if not more. And what this is saying is that this update method is called 60 times per second or so. But we don't know how much distance it should cover in, say, 0.13 seconds, right? But we do know how much it should cover in one. So we multiply distance it should cover in 1 second with how much time it took to run this last frame. Time dot delta time. The last thing is that plus equals over there. And this is really important because we are not actually setting the velocity. I mean, yeah, but it is not a constant velocity we are setting. We are accelerating every time we push the impulse button, so we make sure that this formula that we just typed is actually adding to the previous velocity. Now it should be working, so we hit play and it works. Nice. Great. Now rotation. As we said before, we want the shape to rotate left and right with the horizontal keys. So back to our player script, we create a public variable rotate angle, which is going to be the angle that we want the shape to rotate in 1 second. And we're going to set it to something like 100. Now, we create a new method called rotate, and we are going to pass it as a parameter the horizontal input axis, so we know whether it has to rotate left or right by simple multiplication. We call it from update, rotate input.getAxis, raw, horizontal, and as we said before, with horizontal we get 1 for right, 0 for nothing, and -1 for left. So later on we just get the product of this axis and the angle, and it will turn the angle negative if we are rotating to the left and positive if we are rotating to the right. So back to our rotate method. We need a quaternion to rotate the transform.forward vector. For this, we're going to use the quaternion.angleAxis method. This function asks for an angle and an axis from where to rotate. Imagine you have a wood stick pointing up and you want to tie a rope around it for some reason. The stake pointing up is your axis, and the way we tie the rope around it is the direction of the rotation we can apply. For instance, if we put our imaginary stick here, pointing upwards, we're going to rotate our shape in this direction, right? The same direction where our imaginary rope will be tied to. So this will be something like bar rotation equals quaternion dot angle axis, rotate angle and vector 3 up. Now, as we said earlier, we want to consider whether it should rotate to the left, to the right, or not at all, in case we're not pressing either of those directional keys. So we multiply the rotate angle variable with the parameter rotate direction. And we are almost there. But remember, this rotate angle is the angle it has to rotate every second. And as we said earlier, the update method is called many times in a second. So to fix that, we also multiply it by time dot delta time. Okay, so we now have to rotate the transform.forward vector to actually rotate its facing direction. To do that, we just multiply it by the rotation variable we just created, like transform.forward equals rotation times transform.forward. It is important to always put the quaternion and then the vector tree, because it is not commutative and the IDE will complain otherwise. And now we're ready to hit play again, and oh, I wrote vertical instead of horizontal. My bad. But we fix it, and yeah, it works. So, there we have it. Movement and rotation perfectly working. Please subscribe and follow me on social media if you're interested in being notified whether the next tutorial is up. Next week, we're going to make it shoot some bullets. Link of the project are in the description. See ya!